not be a very complicated thing. Now what we are going to do is, because we're in advanced algebra, we're going to make our solution, now instead of thinking of it as just a solution, we're going to think about it as a solution set, and we're going to make our answer look fancy. Okay? We're just going to get fancy with our algebra today, which is going to be something that you haven't done before. Is everybody good to go?
Yes.
All right, so quick vocabulary. What does it mean to be a linear equation? Again, these are your notes, so you write what you feel like you need to write in them. If you don't want to write the definitions fully, that's up to you. You take initiative on what you want to do. What does it mean to have a linear equation with one variable? If we think about it visually as a graph, what does a linear equation look like as a graph? It looks like a line, right? It can either be diagonal or horizontal or vertical, so it's a line. If I only have one variable in it, what's the most common used variable that we usually use in a linear equation? X, right? But we could use any of the variables out there. Good, so it has one variable, and for it to be linear, if we think about it graphically, that is a line, which means that that variable needs to have an exponent of 1. You guys remember back in Algebra 2 when you guys were classifying polynomials? You had linear polynomials. If it was a quadratic polynomial, what would be the exponent? Quadratic exponent would be quadratic, not 4. Quadratic is the parabola, so it has an exponent of 2. Cubic would be 3. Quartic would be 4. Do these words remind you of anything? Are you thinking coming back to you? No? All right, so now what we're going to start thinking of, instead of just thinking of a solution of our linear equation, we're going to think about it as a solution set. Because as we move further in algebra, we're going to be coming up with sets of numbers that are solutions. Oh, did you get this, Alex? For the book. So a solution set is a number, which is what we're going to be getting today. And for your homework, you're going to be getting just a number in your solution set. But sometimes a solution set could be a group of numbers. And because it is a solution, that means that it's going to make the statement true. So when you plug it back in for the check, you should get a true statement. Okay. So again, it's nothing new. It's just now we're thinking about it as a set of numbers instead of just saying, my solution is. Now we're going to be saying, my solution set is. Is it blowing on you guys?
No, it's fine.
You're okay? All right. And then the last thing we're going to talk about is equivalent equations. So equivalent equations, if you think about the word equivalent, what word do you think of when it says equivalent? Equal, right? So they're going to be related equations. They're not going to be the exact same equations, but they're going to be related equations that end up having the same solution set. I should probably have like the fans blowing on the back end of you guys. Thank you. All right. So pretty much when we find that solution set, it should make the left and the right of the equal sign be the same thing. So those would be your related equations. Okay, ready to do some solving?
Sure, yeah.
Yes. All right. First equation, look at that. So we're going to solve 4x minus 2x minus 5 equals 4 plus 6x plus 3. What would you guys do first? Justin.
Subtract 4x and 2x.
Or say that I would go the other way around. Subtract 2x from 4x. Right. So I would combine my like terms, just like Justin said right here, because they are on the same side. So if I had 4x's take away 2x's, I'm going to be left with 2x. So simplifying the left side gets us 2x minus 5. What does the right side simplify to? And you will find, just kind of give me something. I'm not much of a raiser hand in calling. What do we got? Andrew?
6x plus 7.
Yeah, 6x plus 7. Could I have written 7 plus 6x? Yeah. What property tells me I can do that? What'd you say? No. You're thinking on the right page, though. There's property. Courtney? Yeah, the commutative property. Remember commute? They commute back and forth. Okay, what's our next move? We've got lots of options. I personally don't like to deal with the negative numbers. Andrew, what would you go with?
I was going to say subtract 2x.
That's exactly what I would do, too. Would it be wrong to add 5 or subtract 7 first? No. You just want to move things to get the variables on one side, the constants on the other side. I personally like to deal with the variables first. And because I don't like to deal with negative numbers, I'll subtract the smaller one and move it to the larger one. So on the left side, the 2x minus 2x goes away. We're left with the negative 5. Don't forget that minus sign in front of the 5 equals 4x plus 7. Now we're down to 2 steps left. So what's next? Anybody? Yeah. Subtract that 7 from both sides. A negative 5 and a negative 7 makes negative 12 equals 4x. Maybe you've gotten there already. What's my solution? X equals negative 3. And that's what you guys have been used to doing, right? Box it, circle it, done, done, done. Now, because we're in advanced algebra, we're going to get fancy with our solution, and we're going to turn it into a solution set. You will hear me say set notation very, very often in this course, and everyone hates this. So, you know, like the fancy braces. Yeah, you're going to get really good at making those. So for your solution set, you take whatever your solution is, and you put those fancy braces around it, and that's your solution set. So all you're doing is taking your solution and writing it in set notation. You'll get really good at making these braces. Mine start to get lazy as I go on. I will not judge you on your brace. Okay? Questions? So now we're having a solution set. So when you guys, the odd answers are in the back of the book, and you're welcome to check your answers back there. I do give you odds quite often, though I didn't too much today. They will have their answers in set notation. Okay? All right, let's see if we can do another one. We're just doing 3. That's it. This one and one more. It's not that crazy. We're not getting too crazy today. Yeah. So we have 2 times the quantity k minus 5 plus 3k equals k plus 6. I heard Justin say distributive property. Why would I use the distributive property, Justin? Yeah, get rid of the parentheses. I like that. So when we use the distributive property, 2 times k is 2k. 2 times negative 5 is negative 10 plus 3k equals k plus 6. Now real quickly, I'm just going to pause for a second to talk about my expectations for what you were showing me for your homework. I do want to see steps for your homework, but you may not necessarily, like, for example, okay, so let's combine the left side. I get how many k's on the left side? 5k, good. Minus 10 is equal to k plus 6. If you do not want to show me the subtract k, right here, if you do this, and that's what helps you out, go for it. If you do not want to show me that subtract k and just go to 4k minus 10, if you're good enough to be able to do that, that's enough work for me to see for your homework, but you do need to show me work for your homework. You can't just put an answer, okay, because that's not showing me that you know what you're doing. So make sure you are showing your steps. Me, personally, I need to do the minus k so I'm a visual person. I need to see what I'm doing step by step, okay? All right, next thing we're going to do is add 10. So that gets me to 4k equals what on the right side? 16. So k is equal to 4. Let's make it fancy and call it the set of 4. Okay? It's the only thing we're adding to your life. The braces. Huh? Because when you get into classes beyond this, like in pre-calculus and calculus, you put your answers in set notation, or we'll get into something called interval notation as we move on. So it's just ways that higher up mathematicians show their solutions. Makes you feel smarter about yourself. All right, last one.
Oh, yeah.
Let's see if you can do it yourself. Got all sorts of stuff going on there. Lots of places to make mistakes. So go one step at a time. Make sure you remember to distribute your negative in front of parentheses. And you will also come to find that fractions are our friends in this course. I'm not quite sure what you get for your solution here, but you may get fractions for your answers for some problems. I think this one works out pretty nicely, doesn't it? All right, what did you guys do first? Who wants to share the first step? All right, get rid of parentheses. So if I distribute here, I get a negative 5m. Make sure this became a plus 5. Let me distribute that. I'm going to bring down the rest of the left side. On the right side, if we distribute, do I distribute the negative 5m? Yeah, just the negative, right? So that becomes a negative 2m and a plus 4 plus 5. All right, left side simplifies to what?
Negative 8 plus 11.
Good. Negative 8m plus 11. Right side.
Negative 7 plus 9.
Perfect. Negative 7m plus 9. Check your step as you go. Make sure you're doing it correctly. Okay, which one's smaller? Negative 8 or negative 7? Negative 8. So if I add 8m to both sides, oh, that's nice. That just gets me to 1m plus 9. Subtracting 9 gets us 2. And then make it fancy, because really we're talking about the set of 2. Okay. Questions? Okay, so that's all you're really going to have to do for homework today is just solving equations, and I'm actually going to give you the rest of class to get working on that. Tomorrow we're going to get into how to simplify our equations when we have fractions and decimals. So we're just going to finish the rest of section 2.1 tomorrow with our fractions and decimals, and then we'll be moving on Tuesday. Do you guys remember